Alright, hello everybody. This is our last section in chapter 3. It is looking at linear functions. And one thing that you'll notice is that there really isn't a huge difference in what we've been doing with linear functions and linear equations. We're mostly just changing around some of the vocabulary so you understand this thing, modeling equations with function notation. So we've been doing linear equations. We just want to be able to do the same thing with function notation. Function notation, what we learned back in chapter 1. So let's just we'll review a couple of those things. What exactly does function notation mean? And then we'll do a couple problems together. By the end, you'll know you can do this if you can evaluate a particular x value, and if you can do the opposite of that, evaluate for an x value when given a particular function value. Uh, let's just kind of jump right into it here. So, evaluating a function for x equals something. Recall this notation. This is what we call function notation. And this f right here is simply a label. It is the name of the function. This function is named f, right? It's a very new age type name, f, okay? I can make that f be whatever I want, right? I can make it be h of x. I can make it be smiley face of x. I can make it be frowny face of x. And all of these things are simply labels. They're names, and we can name them whatever we want, okay? The x, all that stuff's in the way. I was going to write there, and then I wrote all that stuff in the way. The x is your input variable. It is the value that you are plugging into the function. You should think of functions as machines, okay? You input an x, and then some higgledy-piggledy stuff in there happens, and then you output the f of x, right? You input an x, you output an f of x. A single number, right? Remember, a function is defined as when we put one number in, we get one number out. If we got two numbers out, it's not a function, okay? So we learned that in chapter 1. Let's just apply that information now to the linear functions that we've done now. So let's say we have this function, and we're going to call it, let's call it neutral face, right? Neutral face of x, or not, what is that? A straight line face? I don't even know what to call that. It's not smiling or happy. You're just neutral. It's what you're all doing right now, staring at the computer screen. None of you are happy, but none of you are sad. You're just zoning into the computer, right? That's what the name of our function is. I feel like it's appropriate. So that function is defined as 3x plus 15, okay? So I'm going to take my input variable, I'm going to multiply it by 3, and then I'm going to add 15 to it, okay? And what I'm going to do is, my instructions now are to find neutral face of x for the domain -3, 4, and 5. So let's just, briefly, what the heck is the domain, right? You guys remember what the domain is? Domain is x values or input values. Domain is representing the x's. So what we're saying here is that what I want to find is, well, what is neutral face of -3? I want to take this function that was neutral face of x equals 3 times x plus 15. But instead of x, I'm going to use the input, the domain of -3. And all that means is I'm going to take -3 and plug it in. And then I'm going to do up my math here. And I'm going to find that neutral face of -3 equals 6. And that right there is one of my answers. But I have 3 of these different domains that I need to enter, so I need to enter all 3 of those. So let's do it again, but this time for 4. And 4 is going to be 3 times 4 plus 15, which is 12 plus 15, which is 27. So neutral face of 4 equals 27. And we're going to do it one more time for 5. Neutral face of 5. That's a funny looking 5. And let's try that again. 5. There we go. Equals 3 times 5 plus 15. Turns out that that's 15 plus 15. So neutral face of 5 equals 30. So this is where we're taking a domain and we're plugging it in to our function and finding this function value, right? Neutral face of 5, that function value. Let's do the opposite of that now. So here we're finding an x value. So let's take a function, and after that last function, you guys are probably feeling a little bit happier. So I'm gonna make this one smiley face of x. Smiley face of x is 2x minus 10. And what I want you to do is find the value of x so that smiley face of x equals 6. And notice the difference in the phrasing here, right? This is saying find the value of x so that the function is 6. And last time we were given an x value and told to find the function value, or to find the function value. But this time we're being told find the x, and we're being given a function value. Notice that we're being told that smiley face of x equals 6. And so what I'm going to do over here is, instead of placing 6 in for the x, I was told that smiley face of x equals 6. So I'm going to replace the smiley face of x with 6. And then I'm going to solve that equation to find the x value. So I'm going to add 10 to both sides and get 16 equals 2x. And then I'm going to divide by 2, and I'm going to get 8 equals x. So I found the value of x such that smiley face of x was equal to 6. We should also note on there that this value, these two values are a pairing. This is your x. This is your function output is actually kind of your y. So if you were to make a table, you've got inputs and outputs. This would be 8, 6. And just like in the last example, let's just go back here. We can make a table for that. If we had x and neutral face of x, our x values were -3, 4, and 5, and their pairings were 6, 27, and 30. We can graph that. Right? This is the x-axis. This is actually the neutral face of x-axis. I know we're used to calling that the y-axis, but here's the thing. F of x and y are basically the same thing, right? So all of these graphs that we've been creating, we can do this in function notation, and it's essentially the same thing, right? Everything we did with the patterns, everything we did with the graphing, all of these are the same. In fact, I can graph this function. Let's graph this function real quick, just for fun, right? This is the end of the video right here, so we have a little bit of time. Let's just graph this. This is the smiley face of x-axis. You might call it the y-axis. Remember, they're the same thing. This is the x-axis. Okay, what's my y-intercept? Y-intercept of -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's my slope? 2. So we're going to go up to right 1. Up to right 1. up to right one. And there's my function. This function right here is smiley face of x equals negative 2, not negative 2x, 2x minus 10. Alright, and that's all I got for you today. So, head back to the classroom. We got a couple things to do.